Hello, Professor. Today I'm excited to present my project, the Intelligent Coding Problem Recommendation System. This tool is designed to help anyone preparing for technical interviews, especially those of us aiming for roles at big tech companies, by recommending the most relevant coding problems based on a job description. So, interview preparation can be overwhelming, and job descriptions are filled with many buzzwords and requirements. With thousands of problems out there, it's hard to know where to focus. My system solves that by analyzing the job description and suggesting problems that align with the skills and role demands. It's like having a personal coach that knows exactly what you need to practice. It reduces the time wasting on searching for irrelevant problems and solutions, and it is very efficient to prepare for such crucial time at interview. Let me walk you through how it works. So first, let's look at the workflow of the system. It's all start with the user inputting a job description, say for a software engineer role at a fintech company. The system then extracts the key terms from the description using a library called AKE, which stands for Yet Another Keyword Extractor. For example, it might pull out words like Python, data structures, or API design. Next, I'm using a powerful model from Hugging Face called sentence transformers, specifically the all mini LML 6 v2 model. This model turns both the job description and the descriptions of over 1,500 LeetCode problems into numerical vectors or embeddings. These embeddings capture the meaning of the text, so I can compare how similar the job description is to each problem. I'm then calculating the cosine similarity between the job description's embedding and each problem's embedding. This gives us a score from 0 to 1, where the score in higher means the problem is more relevant to the job. But I'm not stopping there because to make sure the recommendations are all about one topic, like array problems only, I'm using k-means clustering. This recommend a diverse set covering different areas like graphs, dynamic programming, or strings. Finally, the system displays the top recommendations in your user-friendly system app, completing with an explanation for why each problem was chosen. Now let's dive into the system architecture to see how all these places fit together. The system is built with a clear separation between front-end and back-end, making it easy to maintain and scale. On the front end, I have a Streamlit web application. This is where the users interact with the tool. They input the job description, select filters like difficulty level, and view the number of recommendations. Streamlit was a great choice because it's simply Python based and perfect for data-driven app like this. The backend handles all the heavy lifting. It starts with our dataset, a CSV file from the Kaggle elitecodeproblems.csv, which contains over 1,500 to 1,600 problems, each with a title, description, difficulty, and related topics. I also have pre-computed embeddings for the problem stored in our dataset because the embedding can be used for the cosine similarity calculations. So when a user submits a job description, the backend first extract the keyword and then generate the embeddings with the sentence transformer and calculate the similarity scores, and then it applies the k-means clustering to ensure diversity, generates explanation using LLM. In this case, I'm using Grok from Twitter AI to make the recommendation more understandable and also easy to integrate with the system. The entire system is planned to deploy on Streamlit Community Cloud so it can be accessed by anyone. So this is the user interface of the system where the user can input their job description here. Simply it is the input and they can choose the difficulty and also they can choose the number of problems they want. So this is the backend console and here we can see the local host IP address where the application is being deployed, and you can simply copy paste this in the browser and access the web application. And of course, making sure it works well is another. So let's talk about how we evaluated its performance. To ensure the system provides high quality recommendations, we used several evaluation metrics. First is relevance. I'm measuring this using cosine similarity scores between the job description and the recommended problems. Scores closer to 1 indicate a strong match. In my test, the average similarity around 0.25 without clustering and 0.22 with clustering. This doesn't mean it works well without clustering. What it means is it will simply recommend more, same topic without clustering. So the topic coverage is very low, if you can see here. So with clustering, out of 10 problems, more topics will be covered, like arrays, strings, dynamic programming, and etc. But without clustering, only out of 8 problems, 6 problems are mostly aligns with the same topic, which means user gets a broader range of problem types. This is crucial for well-rounded interview preparation. So in short, while the similarity scores dipped slightly with the clustering, the overall quality improved. So I didn't choose the k-means for its simplicity and effectiveness. But I'm also considering other methods like dbScan, but k-means work best for my need. So let's wrap up with what we have achieved and what we can go from here. So this is the output of the user interface, where this is the input that has been given to it, and these are the problems that were recommended, and these are the explanation that has been given. If you can read this, you can see that the engineer intern, software engineer, robotics team, robotic platforms develop, and advanced robotics. These are the keywords extracted from this job description. So I am highlighting those keywords here so that you can easily relate it. This explanation was generated by the AI LLM. So in conclusion, this project delivers a practical ML-powered tool for coding interview preparation by combining sentence transformers, cosine similarity, k-means clustering, and LLM-generated explanations. I have created a system that's both smart and user-friendly. The Streamlit app makes it easy for anyone to get personalized recommendations with just a job description. And for future work, there's always room to grow. I'd love to add the progress tracking so users can mark problems they have attempted and see their improvement over time. And support for more platforms like HackerRank or CodeForces to expand the problem tool. And I can also able to integrate the real-time JD parsing with more sophisticated NLP to handle complex job descriptions. Like the user can just simply paste the job link to the input, and the rest of all the work that can be handled by the system. So overall, the system is a great starting point for anyone preparing for interviews at big tech companies, and it's been a fantastic learning experience, and I'm excited to keep building on it. And I have also posted all my code files into my GitHub repository, and anybody can clone it and run it in their local machines. So I have also given the instructions how to do it. So anybody is welcome to test this app and give their feedbacks. Thank you. Now let's go to the demo of the application. So this is my backend system. Now I can run this. Yeah, like I said, this is our users interface. Now I'm just copy pasting this job description from Tesla internship, pasting here, and I can select the difficulty. I'm choosing all, and also change the recommended number of problems. So I'm just giving 15 here and get recommendations. And yeah, we got the recommendations. And if you can see, it's data engineer role, right? So you can see how the problems were recommended. You can see the stack problem, you can see the heap design problem, you can see the hash table problems, and also the similarity scores. Everything is similar, I mean, more close to one. And also why the problems were recommended. You can see They extracted keywords like customer experience, statistics and insights, quality and customer data, and meaningful improvements, data requirements gathering. So yeah, this is the output, and like I said, I have hosted my application in the GitHub, and you can just follow this instruction to clone and run it in your local machine. And you're most welcome to test it in your system and give any feedbacks. Thank you.